Good afternoon, everyone. I'm Alireza, and I'm so honored to present today on behalf of my supervisor, Professor Iuorio, Professor Cecconi, and Professor Daniotti from Politecnico di Milano, our paper which is titled Information Requirements and Critical Assessment of Levels. So actually, the topic of my thesis is about the circular economy, so I don't go too much in details about circular economy, just a few words as an introduction, since it is a necessity nowadays in our world because our traditional approach of linear economy of taking material, making something and dispose them is facing a lot of challenge, like consuming a lot of energy, resources, and producing a lot of waste and carbon emissions. So we need to have this shift towards a circular economy. But during the literature review in my PhD, I faced some important research problems, which are data fragmentation and lack of standardization to manage both existing and emerging information requirements, data availability, and automation. So we tried to find a solution, and we saw that the researchers proposed the solution as moving towards standardization and define the frameworks such as circular economy action plan and levels, and facilitate their applications through the digital tools like BEAM, blockchain, material passport, and so on. However, we see that still the industry is too far away from reaching the goals of circular economy. So we tried to do a mapping and define an information management framework which maps the information requirements, both the existing ones and the emerging ones, to a top-down approach to the high-level circular economy standards and indicators from one hand, and from the other hand, mapping them to the sources. Here we, as the scope of our research, we just focus on the IFC and BSCD, as an open BEAM platforms in a bottom-up approach. And you see that the connection and relationship between them are end-to-end, so each information requirement can be used by different standards, and each of the information requirement can be provided in more than one sources and vice versa. So if we have such mapped information requirements and we have a list of them, again, we face some important questions. And these questions will define the aspects of our information management framework. So the first one is that, is this the complete list of the information requirements and all of these presented information are strictly needed or not? And or all of these information requirements is stored or can be stored in a single information container in a centralized approach or not? So we try to develop a dashboard based on the system of the systems to provide and validate if those kind of information exist in our model or not. So the first system is trying to provide the information and find them in a standard attribute and property sets defined by IFC and BSCD documentation. So we develop an ideas based on those information requirements, and we do this validation with the system one. The system two looks for some information requirements which already exists in the IFC model, but not in a standard format. So we use it by the matching, get help from the AI. So the first two systems are for getting the internal information, and of course we need some external information. So we connect the external information containers through their API, like the material passport and digital product passport. And finally, anyway, we will have some missing information, and we need to ask the stakeholders to provide them through the spreadsheets. So this is the screenshot of our dashboard that I have developed. So we can upload our IFC model, choose which kind of information we want to check in our model and validate them based on the strategies and so on. And the good point is that by doing this kind of filtering, we can have our own generated ideas. So if we have our requirements, we will have new ideas that we can apply and validate it through any other tools. Also, we can use, again, these tools to validate these new ideas. And this is a sample result that will give us, and also with some other more details, which shows that how the different systems successfully provided those kind of information that we need in our IFC models. So as the scope of this paper, we just considered the levels framework and try to see that which are the information requirements are needed for the levels and which are the sources that we need to provide. So the methodology that we followed is just 2 steps. Each of them has some inputs and outputs. So first we do the critical assessment of the levels and then try to integrate it with level of information need. So as the case of the levels, we just consider the macro objective 2 and the indicators 2.1, 2.2 related to bill of quantities and construction and demolition waste. And then after critical assessment, we will have a list of information requirements for this level framework, and then to integrate it with level of information need, we just want to answer these 5 simple but important questions of what, why, who, when, and how to provide those information. So the final result would be something like this, a mapping between the information requirements and other aspects. So for example, we see that for the conceptual design, we may require information requirement 1 and 2, which should be provided by the designer and constructor in terms of geometrical and alphanumerical formats. So the results that we have are twofold. One is related to the levels itself, and the second one is related to the integration with the level of information need and the information requirements that we need. So this is a very simple flow chart of how this indicator will work. So we provided a numerical example here, very simple to see which are the critical aspects of considering the levels. And we faced some issues and challenges and some problems during the application of the levels. So the first one was related to the automation, that we tried to address this issue in another paper that we presented last week in another conference. So try to have the bill of quantity using a bespoke Python tool to get the bill of quantity from the IFC. And then the second one is related to the precision. So most of the consideration in the levels are based on the assumption of the materials. I don't go too much to detail because it's related to the levels, but it ignored the residual value for materials with higher lifetime, and also it underestimates the required material for materials with lower lifetime. The indicator 2.2 is even simpler in use. So this is the flow chart for that one. Again, here we see that we still face the problem in terms of automation and precision. And here we have the lack of key performance indicator for waste categorization. Again, in that paper, we try to solve this issue by assigning automatically the European waste catalog and codification of the waste to the materials by using the AI and some other challenges. So this is the list of information requirements. So this is the second part of the results. This table is available in the paper. I don't go too much in detail, just I want to highlight that as we can see here, for example, the bill of materials, European waste catalog, or some of the information requirements are not provided in both indicators, and also we see that the information requirements that we have are provided in different information containers. So as a conclusion, here just I put some of those information containers connected to the levels, and if you want to back to our main question, to see that is this the complete list and are the information requirements strictly needed. We see that the information requirements across different standards may be different both in terms and also the type. So we need an adaptable and scalable framework capable of addressing both fragmented existing and emerging information requirements and move towards the minimum information requirements rather than maximum one. And also we need integration of digital tools such as BEAM to facilitate the application. And as we can see, not all the information are provided in just one single information container, and we need to have a concept of system of systems and move towards decentralization of the data. A special thanks of me will go to Dr. Mustafa Seljuk-Sedik and Dr. Karim Falkari, who is here for the collaboration that we had over a year and their warm hospitality during my visit in UCL. Thank you so much, Karim, and thank you everyone for your attention.